So let's move to the reduction formula. So you have 0 degrees, 90 degrees, 180 degrees, 270 and 360. Then I have written ASTC, so of which I am going to explain what it means. So I have cos, sine and tan. All the trigonometric ratios in this quadrant, the first quadrant, are positive. Here only sine is positive, here tan only is positive, and here cos is only positive. So we say all students take cake. All students take cake. All right, so the angles that you're gonna find here, it's 90 plus, it's 90 minus theta, it's minus, and 360 plus theta. Okay, this side you are going to find 90 plus theta and 180 minus theta. Here you will find 180 plus theta and 270 minus theta. Here you find 270 plus theta, 360 minus theta. Okay, what does this mean? It means that when cos comes in, when cos is in the second quadrant, it's negative, and when tan is in the second quadrant is negative. It's only sine that is positive here. Only tan is positive and only cos is positive. Here all the trigonometric ratios are positive. Right, so now we say sine into 180 minus theta, sine into 180 plus theta, cos into 180 minus theta, cos into 180 minus theta. Okay, and tan into 180 minus theta, tan into 180 plus theta. Okay, here plus. So this tells us that this is what we are going to find. Sine in 180 minus theta. 180 minus theta is in the second quadrant, so that means sine is positive. You're gonna have sine theta. Then you have sine into 180 plus theta. 180 plus theta is in the third quadrant, so then it's going to be negative sine theta. You have cos into 180 minus theta, which is the second quadrant, then cos will be negative. Cos into 180 plus theta, second quadrant, negative. Third quadrant, negative cos theta, negative cos theta. Tan into 180 minus theta, it's in the second quadrant, so it's going to be negative tan theta, right? And then you have tan into 180 plus theta, which is the third quadrant, then it's going to be positive tan theta. Also have now let's do the 360 minus and 360 plus. Sine 360 plus theta, sine 360 minus theta, sine 360 cos 360 minus theta, cos 360 plus theta, tan 360 minus theta, tan 360 plus theta. Okay, so sine in 360 plus theta, 360 plus theta is in the first quadrant, so sine is positive, right? So we're gonna have positive sine theta. Then you have sine in 360 minus theta. 360 minus theta is here, fourth quadrant, it's gonna be negative sine theta. You have cos into 360 minus theta, 360 minus theta is in the third quadrant. Cos is positive. Cos theta. Cos into 360 plus theta is in the first quadrant, so cos is also positive. Cos theta. Then we have 10 into 360 minus theta. 360 minus theta for 10 is in the fourth quadrant, so 10 is negative. Then you have 10 into 360 plus theta. 360 plus theta is in the first quadrant, so 10 is positive. 10 theta. Right? So now, let's go to what I call co. Okay? Co is what you would know as co-functions or co-ratios. So we're talking of sine 90 minus theta, sine 90 plus theta, cos 90 minus theta, cos 90 plus theta. So the 90 and 270 works the same. So but we're just gonna do for 90. But 90 and 270 works the same. You will notice here that there is no 90 and there is no 270. So because it's covered under, it falls under cofunctions. Okay, so then let's look at it. So sine into 90 minus theta. So firstly, the co means you're looking at this. Where you see co, that means you're gonna subtract co. Where there is no co, you are going to add co. Look, you have sine and then you have cosine, right? So that means the cosine has co, you will subtract co. When are you going to subtract it or add it? First, you look at, you have what? You have sine into 90 minus theta. Firstly, you look at the 90 minus theta. Where is 90 minus theta? In which quadrant is 90 minus theta? You check. 90 minus theta is in the first quadrant. So that means sine is positive. So now that you know that sine is positive, you are going to leave it like that there. And then so, do you have co? You don't have co. So it becomes cos theta. Right? Okay. Then you come here also. You have sine into 90 plus theta equals to, you have sine into 90 plus theta, right? So you check 90 plus theta is in which quadrant? Is in the second quadrant. How is sine there? Sine is positive. Right, you don't have co, you add co. Cos theta. I'm sorry for the noise. And then you have cos into 90 minus theta. You check 90 minus theta is in the first quadrant. Do you have co? Yes, you had co, so you subtract co. It becomes sine theta. Then 90 plus theta is in the second quadrant. You have co, you subtract co, becomes sine theta. Okay, that's it. So the co, these are the co-functions and the values of, this is what we would then call the reduction formula, is what you use to reduce when you are maybe trying to simplify or working with trigonometric identities. When you are simplifying trig questions. Okay, now let's move to spatial angles. So spatial angles, they are paired with spatial triangles. Okay, so triangle 1, you have this triangle 90 1 2 root 3, right? 30 60. Triangle 2, you have this one whereby you have 45 45 1 root 2. Okay, so you are going to look at sine 30 degrees, sine 60 degrees, cos 30 degrees, sine 60 degrees, and tan 60 degrees, and tan 30 degrees. Okay, so now look at remember the SOHCAHTOA. Okay, so sine 30, sine being opposite over hypotenuse, 30 becomes our reference angle. So you like, which side is then opposite to 30? Side opposite to 30 is 1. The hypotenuse is the longest side, which will be 2. Therefore, sine 30 will be 1 over 2. Then you have sine 60. Okay, sine 60. If 60 is your reference angle, the side which will be opposite to 60 will be square root of 3. Then it's square root of 3 over 2. Okay, and then you have cos 30. Cos 30, this is the reference angle. Cos is what? It's adjacent over hypotenuse. Then this is the adjacent, that's the hypotenuse. Square root of 3 over 2, right? Then you go to, sorry, supposed to be cos again here. I'm sorry. Cos 60 degrees. So cos 60 degrees, so 60 is the reference angle now. This side becomes the adjacent side, and that's the hypotenuse. Then it's 1 over 2. Then you have tan 60. Tan 60, 60 is the reference angle, 10 is opposite over adjacent. So if this is the reference angle, this side is opposite and that one is adjacent. So it's going to be square root of 3 over 1. So you can just leave it as square root of 3. So then you have tan 30. Tan 30, it's what? Opposite over adjacent. This one is opposite to 30. This one is adjacent. 1 over square root of 3. But punching tan 30 in your calculator, you could get tan 30. You could get tan 30 as square root of 3 over 3 because the denominator has been rationalized, which is why the questions will say without a use of a calculator. Okay. Now let's move to 45. You have sine 45 degrees, cos 45 degrees, and tan 45 degrees. Okay. So you look at this, sine 45, whether you choose this sine or this, this angle or this, it's 45. So what then you are going to do, you are going to say sine is what? Opposite over hypotenuse. So it's going to be 1 over square root of 2. Again, 1 over square root of 2, if you rationalize the denominator, you could get it as square root of 2 over 2. But this is the answer without the denominator being rationalized. Then cos 45, you're going to get the same thing, 1 over square root of 2. Because if you say you're focusing on this 45, it's 1 over square root of 2. Then tan 45, it's 1 over 1, which will give you 1. Right. So, now I would like you guys to do some questions under trigonometry, and then you just prepare yourself for whatever exam, whatever test that you will be writing. So we're gonna hold it here, and then watch out for the next part where we are just revising or looking at the double and compound angles together with the general solution. Please don't forget to subscribe, like the video, and share it with your friends. Cheers.